Case number 8. Look for the identity which is equal to the result when we divide the tangent squared y by secant squared y. We can solve for the identity of this given by expressing both of them in either cosine, sine, or combination of both. Once we can express them in those 2 or 3 possible forms, then we might be able to see processes to cancel or simplify our result further. We know that tangent y is equal to sine over cosine. But what is tangent squared y? You don't need to worry much about exponent of a singular trigonometric identity, since it would matter as to the exponent of its equivalent as well. Again, tangent squared y is sine, let's start. Tangent y is sine y over cosine y. This is just for tangent of y. But since it's tangent squared of y, we are also going to place a square here and here. It should be both the numerator and denominators to contain the square so that it would retain as tangent squared y. Because in this case, you can take out the square and you will have sine y over cosine y, which is again tangent, and the square of it is tangent squared y. At the bottom, our secant squared y, or secant y, can be expressed as 1 over cosine y. But since again, it is secant squared y, so we are going to place here square here and here as well. But since our numerator here is just 1, so the square of 1 is 1 itself. Now that we have established the equivalence of tangent squared y and secant squared y in terms of cosine squared y, sine squared y, or combination of both, let us try to examine that we have here a quotient of 2 different rational expressions. When we are dividing rational expressions, just like dividing fractions, we are to use the keep, change, flip method. The keep, change, flip method means we are going to keep our numerator, the entire numerator here, it's sine squared y over cosine squared y. The numerator is retained as it is. Now, instead of division, we change the operation into multiplication. Then, for the flipping of our denominator means we are to reciprocate it. So instead of 1 over cosine squared of y, we have here the reciprocal of that, cosine squared y over 1. So again, we kept the numerator, we changed the operation from division to multiplication, and we flipped or we reciprocated our denominator. And with this, we can proceed by multiplying numerators to numerators and denominator to denominator. But before we can do that, we can actually see here the presence of cosine squared y and the denominator as well as a numerator. So we can simply use the cancellation law for multiplication, leaving us with this result: sine squared y over 1, or simply equal to sine squared y. This is now the identity that we have found by simplifying the quotient of tangent squared y and secant squared y. It's sine squared y over 1, or simply sine squared y. This case for missing identity is now closed. If you may, to be ready for some new cases, subscribe now.